That is not, I mean, but it's possible, it's happening. So like the moment you get into say like Walmart store or some other store, they are saying that okay, surveillance camera and all this thing. But behind the scene, they are processing all this information to get into like who are coming in our store, how much time you are spending. Just to think from the restaurant point of view, right? Like, I think here in Chicago there is a company which does outside the restaurant, they have put the camera, right? And we have studied in marketing that footprints, right? Who are working outside the restaurant and how out of those people, how many of them has come inside and then how much time they have spent. All these matters to from the operation, from marketing point of view, right? So this is how it's changing the whole game. Anybody else? Okay, so the other technique which is called recurrent neural network. So we saw the CNN, which is more like a image processing, but the world is not made of discrete. So sometimes you need to process the information which is in the sequential order. So what do you mean by sequence here? Sequence means when we spoke, the spoken language, the understood by other person, it depends upon the what we have spoken in sequence. For example, say like when I say I ate apple and then the next sentence is I have an Apple iPhone. So here the word apple, the context matter here. What I have spoken earlier, what I have spoken later, right? So how can we model these kind of sequences? So this is where the what we call recurrent neural network has come into picture, and it is also made of a lot of neurons, and the output depends on the sequence, the hidden state, and there are two kind of neural networks are there. One is called feed forward, one is called simple RNN where the information process in one direction, but in the bidirectional RNN, the information process in both direction, and finally you augment the output from the both network and then you produce the output, and it has like multiple applications which I'm going to talk about next. So here is I think none of these things you guys should be familiar with what I'm talking about. Right? Alexa, probably everyone either have it, right? And then chatbots and speech generation, right? So the science behind Alexa is all about neural network. So how, when you say something, Alexa, can you play a music for me? So this information is processed by Alexa, and behind the algorithm which is being used behind the scene is RNN. And then Alexa, what you call something called intent detection in machine learning. So it detects the intent. Intent means what you want to do, and then it gets the information from the relevant databases and provide it and play back to you. So this is what it means. Then second example is the chatbots. So probably most of you guys might have encountered one customer website or other customer website chatbots, right? So now everybody want to reduce the customer service cost, and the best option is chatbots, right? So the science behind chatbot is recurrent neural network. So basically, again, you think when computer have to detect, they detect in sequential order, right? Like what you have spoken earlier, and based on that, I will take the next action. So this is the holy grail of what you call the application of RN, what is called the language model. So I'm not sure how many of you have heard about Google Pixel. Google Pixel 2 phone can translate your language in earbud. And that is possible. How is possible? Because it's this RNN model. And this is the architecture on which they have built it, machine translation. And here, this is you are translating from English to Vietnamese. So anyone has any question?
So is the goal here to improve accuracy or to provide real-time translation?
This is the real-time translation.
But the reason why we use this kind of technique is for it to be used in real-time processing.
Yeah.
Not maybe more accuracy is a byproduct of that.
No. See, so there are two benefits, right? First, the real time, and second, the accuracy. So this technique are much have higher accuracy as compared to if you do some earlier there were like a template-based translation or something like that. And then the third technique is called reinforcement learning. So what is this? What is reinforcement learning is different from what we have supervised learning and unsupervised. Here, the key here is you don't have any historical data, no prior data, right? So you have to make a decision given in the current environment. For example, say like when airplane flies, it doesn't know how much pressure, how much, what is the speed of the wind, and it has to adjust itself according to the given condition. That's how, this is what is called reinforcement learning. And the best example is AlphaGo and the game which I talked about. It is based using, computer is able to beat AlphaGo champion because of this technique, which is the reinforcement learning. And then how you can apply reinforcement learning in your day-to-day life, right? So now we are hearing that robots are going to take over our jobs or whatnot. They can be very helpful also. So what robots does here is they take the picture, they determine the angle, and they take the action, right? And then the reward is distributed to them. What will reward it? And then from our perspective, those who are in the MBA, just think from the supply chain point of view, right? So you have current inventory level and the sales history, and then you determine how many more units I need to purchase so that I can make the profit, right? You can model all these things in reinforcement learning. And then finally you have different kind of games. Those who play games, they must be familiar with like that is AlphaGo and how it can going to help. So any question? Okay, so I'm going to talk about now real world. Now let's come back to real world. So here the challenge is when you go for fishing, a lot of camera is put on the board, on the fishing board. So how can you detect not only the fish from the images, but you have to detect also the species of the fish? How is possible, right? So this is the real data which is given by the client. And just you think how messy this data is. And out of this you have to detect the fish species, which species it belongs to. So when you go and try to build a model, the first thing is you should know your data, like training data, and especially the sample size, how the sample is distributed, because you have to find 6 classes here. So you guys understand what you mean by unbalanced data? The dead classes should have some foundation on unbalanced data. So unbalanced data means when you try to train a model and you have highly unbalanced data, so model will try to skew the output towards the unbalanced data. And here, this is the class which is very high in the number. So your model will be more likely to be skewed towards that. Right? So we have to do all the pre-processing, balance, some based on the weight. And if you go to the real world, who wants to get into this kind of hands-on thing? So the other challenge is when you take the frame from the video, you will see the same kind of images, and which is very hard. There is no variety or diversity, right? So those are the problems you face. And finally, especially in this case, how you detect different kind of tuna, which looks more or less and very, very similar. So what I'm trying to explain here is because of AI techniques, although there are even the slight differences there, the computer is able to detect whether the difference, if sometimes where we as a human being or trained eye, even we fail. Anyone has any question?
So would this be an example of reinforcement learning where the
No,
computer learns
this is
over
the
time?
example. I'm coming to architecture. Yeah. So this is the output is the same CNN. No, but here, see, reinforcement learning will be not applicable here because you have already pre-trained data, right? And based on that, you train the model. Basically, the way our brain functions, we train our brain in some way, and then new data will come. Then it will tell, okay, this is what this variety is. So here, what you have to do here is something called object detection, right? So out of the big images, you first need to identify where the fish is, and then once you got the images, you have to classify which class it belongs. This is much harder problem. Anyone here?
So how important is it to have the quality of the image over here? Because let's say if you train your model based on a suboptimal image or something like that, or the other way around where you have a perfect image of those fishes, but then in real time you get a suboptimal image. I mean, that's going to completely skew the information that you're going to be getting.
No. So this is the power of, see, the data set. This is the real data. This is very noisy data. Look at, right? So the good thing about deep learning is, we don't need to do something called feature selection. Feature means what is important for me. For example, some image having the very good quality. Some of them have like a very noisy image, right? So when you train the model, you make it bad. You should have the good images, you should have the bad images. So that computer can learn, even in this scenario, what is the output I need to produce, right? So quality matters, but it's not that matters. But so you have to train the model accordingly. So it's like the exactly same thing, the way our brain functions. If we teach our brain some good thing, it will learn some good thing. But if you teach some bad thing, it will learn bad thing. Yeah.
So how is it different? We have causal algorithms and all right now, right?
Which one?
Causal algorithms in supply chain and all that, where you on promotions. Is this like the next step of it?
Yes. So I think, look at here. Look at here, this is the evolution. So your causal algorithm will fit somewhere here, right, in supply chain. Because I think so far, till here, so far a lot of people are using like linear classifier. If you go to the next level, something called support vector machine, right? So these are the algorithms which are available since like 70s or 80s, and people are using on and off. So now what has happened that something called back propagation. So when you train the model, let me explain you something like this. So when we don't know the things, right? So the probability, the error will be very high, right? But when we started knowing things, the error will reduce and it will converge, right? So this is the core concept here, and something called back propagation. So what happened that you don't train in the forward, you take the output in a one step and go back and feed the error to as an input. What is called the back propagation, right? In every step. That's why this mechanism has much higher accuracy. So if you talk about this CNN, the accuracy rate is almost like a 98-99%. And you go to all the linear regression or SVM or other linear classifier, its accuracy is around 75 to 80%. So that's the fundamental difference. That's why everybody is running after, and everyone wants more accuracy.
So even when you're training the models, like is there like a minimum quality you need? Because if it's like
No.
so bad, then if it's like literally,
I
but there has to be
at
some
least
point where
our-
it fails,
see,
right?
okay, let me
Like,
tell you. Whatever we can identify by our eyes, the same thing computer can understand. Like we should know, or sometimes better than our human beings also.
no, I couldn't tell the species of the fish there. Like even if someone told me,
right, it's better than human, right? I mean, this is the classical example of power of AI, right? It's like this is, I mean, can you identify what is the, which tuna is which? Right? In this picture, can you identify which tuna is which? Right? No, right? So computer is getting much better. Right? That's why people are scared. What will happen? Is it going to take our job? Probably yes. Right? But again, it's the human evolution, right? If something, there will be always next thing for human to do. We are better than computer, maybe not. Yeah, go ahead.
But it's kind of along the lines of the way the mind might work. The mind gets smarter, and with any particular image of like the albacore, for example, they made a correct prediction as albacore. The model gets better, and several months or years later, presented with the exact same image, will it always reply with albacore, or will there be some? How do you retain that learning?
Say again.
Okay,
Can you
so
rephrase your question? Yeah.
it was a correct prediction, but it fed the same. If the model learns, fed the same image, will it also make the same prediction or classification?
No. So here we have to do one thing. So when we are training the model, so training data set and the test data set will be different. So we will not train the model with what we are going to the testing.
Of course, yeah.
So the model doesn't know what will come with the unknown data. From model point of view, it's unknown data. That's why whenever you have data set, you split into three parts: training, testing, and validation. That's how you know. Otherwise, what will happen? Something called overfitting in the machine learning. So it will extract the same kind of features, and then it will understand, okay, I know what you are talking about, so I will predict the same thing again and again, which is not good, right? So, and then one unknown data will come, then it will fail.
I think your question was more around whether it loses that learning over a period of
Yes.
time. It doesn't.
No.
So yeah, a working model presented with
No,
the
no,
same
no, no,
problem.
No. It
will
will never.
always
Let
have the
me
same.
give you an example. Google Map. How do you know there is a traffic jam from here to the next street in how much time? How it works? Right? It gives more or less accurate almost every time. Google Map. So what happens that is Google has automated whole thing, right? So when you say like very first time, just to think the first time, right? You go from here to there. So it takes